Hello, I want to talk today about the 3 rules of compensation. Why? Because compensation is such an important thing to get correct when running your experiments, especially if you're doing polychromatic flow cytometry, which many of us are doing nowadays. So the 3 rules of compensation are: first, that the control fluorescence must be at least as bright as experimental fluorescence, if not brighter. Second, that the background fluorescence of the carriers of a positive and negative sample must be matched. And 3, that you need to have identical characteristics between the control and the experimental sample. Now, the first rule, we need to have the control sample at least as bright as the experimental sample, because when we calculate compensation, we want to get an accurate measurement of the slope of the line between the negative and the positive, and the more accurate that measurement, the better. So at a higher fluorescence, with more photons being collected, we get a better signal. Implicit in the first rule are the fact that the signal is on scale, so we need to be in the linear dynamic range of the PMT detector, as well as in the on scale of the detector. If you're off scale, you need to think about reevaluating how you set up compensation, especially when you're developing a polychromatic panel. I recommend that you make sure that your compensation is accurate and make sure your compensation signals are on scale. The second rule is that the background carrier of the negative and the positive have to be matched. Now, since compensation is a property of the fluorochrome, not the antibody or the carrier, you can use beads or cells, and you can have beads and cells in your sample compensation matrix, but you need to have a positive and a negative for both, because you need to have the same background fluorescence on the positive sample that is on the negative control sample. The third rule, which is most important, is that you need to have the same fluorochrome, and you need to have the same fluorochrome and the same sensitivity. So this means you can't use FITC to compensate GFP. Even though they both are green and they both are typically measured in the same detector, they're very different spectrally. More importantly, this is critical for tandem dyes, which are man-made and will have different variations lot to lot. So you really want to make sure that you use the same tandem dye, which is why beads are useful. The second thing is that you have to have the same sensitivity. So that means you need to have the same voltage. So that means that you do not want to be reusing your compensation matrix day in and day out, because your voltages may change over time. Even a small 5-volt change can impact your compensation. So those 3 rules which we talked about, you can Google them. You'll see there's a lot of written about them. Remember, compensation control must be at least as bright as your sample. Second, because compensation with the fluorochrome and not the carrier, you can use any carrier, but you need to have the background of the negative and the positive. And finally, you need to have the same fluorochrome, both fluorescently and based upon the sensitivity. Thanks a lot, and pay attention to us here at Expert Cytometry for more information on flow cytometry best practices. Cheers.